Hello and welcome. I'm Shadow of Shadow Gaming, bringing you episode 13 of Programming with Shadow. In today's in today's video, we are going to continue looking at object-oriented programming, looking at inheritance a little more, and doing another example. In my example today, I'm going to do calling it shape drawing tool. The idea is I'm going to have a shape base class, and other shapes are going to inherit it. It's going to have a perimeter, a get perimeter, a get area, and a draw method. The idea with the draw method is it's going to just draw out a console representation of the shape, stars on the console. The other two, get area and get perimeter, estimate the areas and perimeters based on whatever you give them. So let's go ahead and hop right in. So to begin with, the first thing I'm going to do is I'm going to just create another file, and I'm going to call this shape CS. So first thing we're going to see is a new keyword, abstract. We haven't seen that yet. So abstract says you can't create, or it basically tells you that you can't create this class. It tells you can't create this class, but then you can still inherit from it and use it. That's what we're going to do with it. We're going to give it a public string name, make this getter and setter, spaces around that just because that's not the style. Let's do a constructor. We'll set the name here in the constructor, so we'll probably shape. Let's do string name. Equals name. Yeah, we'll remove the setter here. We don't want to set it. Now we're going to see that keyword again. Public abstract double get area. So this means anyone that inherits from this has to create it. One new thing here is that notice I don't have any braces. You actually use a semicolon. That's the end of the thought, and whenever they fill it out, that's when they'll add the scope. I'm going to do the same thing with a perimeter. Get perimeter. But now we're going to see a different one. We're going to have a default draw. And we use virtual for that. We're just sort of seeing that how we use these slightly differently here, wherever they are. Virtual means you can override it, but you don't have to. Abstract means you have to override it. Name here is the name of the shape. Capital N. All right. So there we go. So there we got us a shape class. Good. So there's this thing. Do another shape. Create. Let's do a circle first. It's the one that doesn't fit into this because in a circle perimeter would technically be named a circumference, but we're going to consider it perimeter just so it'll fit in with the next one, rectangle. So let's remind ourselves how to inherit. So we do public class circle, and we put a colon, and then what class you're inheriting from. Okay. So public double radius. Yeah. I'm going to do this the same way. I'm going to set it in the constructor. Radius base circle. So we're saying I set in the name of the circle. We'll set radius equals radius. This should have been a lowercase. So there we go. There we still have a problem. We still need to override the two. Now we've got us a circle. That's the name of the base class and circle, and we set its radius. So now let's override the method. There's things you could do here. Let's do public override double get area. There we go. It went ahead and implemented it, but it's throwing a not implemented it. So what we're going to do here, let's do return 3.1415 times radius times radius. We know the area of a circle is pi times radius squared. So we could hard code a radius here, but there's math in C# already. We can do math dot pi. This one's a much more accurate one than what we're going to see. It goes a little further. So we're going to use that instead. So technically we're using the math class here and we're using pi, but this is a little bit different invocation than before. And what this is it provides constant and static. So this is how we would do it. Static property or static constant. So here's how you could do this. Another thing, since this is one line, a lot of times you might see this like this instead. This is called an expression body member. May not be 100%. You remove return. So this is shorthand for what we just had. So that what we just had was the exact same thing, but this is a shorter version. Let me just undo that actually. Let's do that, but let's comment this out. Let's do it again here. It's public override double get area. Now area go away. Then we draw an arrow. Math.pi times radius times radius. So you'll see that sometimes, and I would say for this case, it's actually a pretty good case. It's doing anything special here. But just remember that if you see that, that's equivalent to what we've got below. Thing to remember is there's no return, but there's implicit. It can tell you're doing a double and you're doing something here. Tell that that's return a double by that. We could do the same thing for the next one. So we could do override the perimeter of a circle is called, as I said, it's called a circumference. We could do get perimeter. You notice it favors that. That's a setting somewhere, I'm sure. So 2 times math.pi times radius. I think that's right. Yeah, I believe that's the circumference of a circle. It's been a while. I think that's it. So now let's override the draw method. So remember, well, the drawing help or the formatting helps annoying me today for some reason. So circle, it would be hard to draw, so we're just going to do a symbolic what it would look like. Oh, and once again, we had to override these two. We didn't have to override this. In fact, if I could comment this out. So now, if we look at it, it's telling us there's an error. Circle does not implement the abstract class get perimeter. If we try to build it, we'll get that error out of it. So that one, it's saying that that's required if we're going to inherit from a shape. But draw, on the other hand, I can comment it out. comment it out, we don't get the a warning or error here. We could build this if we really wanted to tell us it's right. Let's do that. Do shape circle equals new circle. Now let's say 3. I might have just added circle draw. Should see that this works. See if I've made a mistake somewhere. And it should tell us the name of it's a circle or a store. Drawing a circle. Here we go. So there we can use the default. However, we can also override it. That's what the virtual stands for. So let's override it and let's represent a circle. So let's do, I think 2. I might be wrong on that, but you might have to adjust here and just copy, paste, paste. Thinking is that we'll do this like this. I think that'll draw us a decent enough circle. Let's see what it looks like. Might need one more side. That actually looks alright for ASCII art circle. Actually. Yeah, we'll go with that. That actually looks decent. I was thinking I might need to add a 3rd layer in the middle, but looks acceptable. So there's just a circle. Let's do another inheritance. Let's do a rectangle. So let's do rectangle CS. Is that right? Wait a minute. Yeah, I think I did. Public class rectangle shape. So inherits from shape. So let's see what this warning is. Let's see if it won't let us. So it'll let us implement the contract. There we go. So there's just what we have to do. Generate a constructor with name. That's not what we want though. We want rectangle. You can define it by width, height, or width and length, or width and something. Let's do public double length. We'll do this as a get only. This would be a read only is what you would say this is. Name, we'll do name, spell it, double length, double width, there we go. So there's just most of what we need. Let's see. Let's implement get area. Get area is easy. It's length times width. So return length times width. Here, I'm going to do this. Use expression body for member. That's what that's called. Expression body, which I think that's what I said. I think I got it right actually. But yeah, you'll for little ones like this, I would probably just go ahead and do that. Me, that's just as readable as seeing the method, but here might be easier to see the braces here and know that it's a method. How you can tell is it this while a property doesn't have it. That's how you can tell the difference. Oh, let's see. So turn 2, put it in parentheses, 2 times length plus 2 times width. There we go. There's a perimeter. Since there's 2 2s though, let's just factor that out. Get all this and 2 times that. There we go. So there we just pulled out the 2. So I just clicked. Now let's do a draw method. So I think I'm going to loop over it. So basically loop and create each line. Yeah. I might consider doing it hollow, but let's do it solid first and we might come back to hollow if we have time. So I think that's going to be more annoying than useful for what I'm going to show. Let's just draw it first. So let's do for int I equals 0, I less than do length. Nope, it should be length. We'll treat length as up and down, so this way is length. Probably should be height. Let's do that. If we do F2 here, we can say height. That'll make more sense from the terminal perspective, probably. So there, one thing to keep in mind is that height, since we're doing less than, alright, but we're doing equals, we have problems because height's a double. Well, this is an int, so it would never equals, but we're doing less than, so it would be good. Let's do console.write line. Let's see a new method we haven't seen. So I mentioned earlier that strings are a little different. The reason is strings are an object like we're using here, so we can do a new string. I'm going to say new string, and I'm going to say star is character, and look here, the next one's count, and it just says create a new string with this many characters, and make all the characters this. Let's do int width. There we go. So it says make a string of characters this and have this many. So if it's a double, we're just going to cut it off and represent it as like that. Let's go over here. We've got 2 shapes now. Let's do this a little better. Let's do shape, array, shapes, equals, new circle. Let's do 10 just to make it easy to do my counts here. New rectangle. Do 4 and 6. I'm just making these up as I go. We might have to adjust to make it a little easier to think about. So let's do for I equals 0, I shapes dot length I plus plus. Just loop through the shapes, and now we'll do dot right line. Let's do shape, and we'll put the name. Shapes dot name. We're going to use it a couple times. Let's do shape shapes at I. what I'm doing here is instead of having to access it each time, I'm just going to save it off and access it once, because I'm going to do it a couple times. So there's one line. So that right line. Do area next. Let's do perimeter next. Let's do area. This doesn't matter. It's whichever one you would probably, but I'm going to do area because I think the area is going to be easier to see. Perimeter. Get perimeter. Now let's do draw it here. So draw handles that. What we could do instead is return a string from draw and print it here, and that probably be a little better design. We may think about switching that, but may not. And then let's add an extra line here. I think that's what we want. So that will run each of these and then print. So let's see what happens. There we go. Yeah, that looks decent. The perimeters. Oh, didn't put braces. Try again. Let's check this. There we go. So I think these make sense. So the area is pi times radius squared. Radius squared would be 100, so 314 seems all right. 2 times pi radius, so 10. 2 double 314, so that seems right as well. Area, let's see. Numbers that I use? 4 and 6. So yeah, that seems right. And then you would have a rectangle 6. 4 is 10. More is 16, and 4 more is 20. Seems right. So I think I've got my calculations right. Done, or should for what we're doing, but I think they're right. Let's add another one. Let's add one more, and we'll do a triangle. Yes. So I'm going to think about triangles as being isosceles for. That means. No, let's think of them as right. Yeah, I think I want right. Go to paint. Yeah, I think I'm going to think of them as isosceles, but draw them as a right triangle. So what I'm thinking of is something like this, and then I'll give them a height, and a base, and there we can calculate it because then we know we would know this side. We could half it. So 1/2 base. Height, and then we have the two sides, and we can calculate the third with hypotenuse equals c squared plus b. Yeah, I think that's what I want to do. So let's go about that. Let's see. Wait for me. Let's do this and do. So this one's going to have the most chance of error. So I'm going to do a little bit of rounding, most likely. Let's see what we can do. Public class triangle shape. Abstract class. Enter this, but that's not the value I want. Let's do public double base length. Get. read only getter, public double type get. Could use base here. Since it's uppercase, that would be fine. Here we would use we'd have to do something different though. We'll have to say at base. That's probably fine. There we go. So there's us a triangle. Let's do these methods. Let's do the draw first. So what I'm imagining for the draw is we'll just do a power of triangles. Let's do did that again. Need to figure out which one that is. That one's annoying. Let's say row row equals 0. Row, let's do height. Row plus. I think this will do what I want. Another thing. So if I do, we'll just add these here. So console.write line new string. Do the same thing we did before. What happens here? I'm not actually sure if this is what I want or not. Do row plus 1. There gets us it'll do a 1 on the first one, 2, 3, 4, so forth. That's not going to take into account the base is smaller though, because it's just row. Let's think about that though, and we'll come back to that. Let's do the area first. Area is easy. It's already in the correct format. We can just do return half 0.5. So that's 1/2 base times height. And we're done. We'll make it an expression body member because we. So perimeter, on the other hand. So here we're going to have to think about this a little bit. So we need to define it as half. Let's do double half equals base length divided by 2. We'll make it a double. So there. So that's half a triangle. Back on my picture, it's like half of the triangle. So then let's do double hypotenuse. Let's not try that. Let's do side C. I'm not going to try to spell hypotenuse here. Yeah, I don't think I can. Do square root. So another math method here is square root. So we don't have to do the square root ourselves, which is nice. So what we're doing, let's go back over here. So what we're doing is finding the area of C. And to do that, we take the square root of both sides. Then we have C equals square root of squared plus B squared. It's technically plus or minus, but we're going to drop the minus. Because we're doing with shapes, so we need real area for what I'm doing here. So we could do this. We could do half times half. And that's half squared. That'll work. You could also do this math.ow. Then value is height 2. There we go. So these two are equivalent. I would say this is perfectly fine for 2. If you were doing more than 2, you'd probably want to do this. Let's do this though. Let's return base plus 2 times C. So what we're doing there is we're saying, okay, add this amount plus this amount plus this amount. That should be the perimeter. Have to be careful with their picks though, because otherwise we'll get into rounding. Let's see what this does. I may want to adjust this draw, however. Let's add a new triangle. Let's think. 3, 4, 5. So let's do let's say the base is 4 and the height is 3. So the hypotenuse should be 5. That should be alright. See what that gives us. Yeah. Area of 6. 2 times 3 is 6. Yeah, so that seems right. Perimeter, that's a little hard to tell. So let's see. Base of 4. 5 and 5. And that seems a little off. The math may not be working right. Pull up a calculator and check that. So let's see. So we have we say this is 4, so each one of these is 2. This one's 3. 4. 2 and 3. Get 9. 9 plus 4. 13. Square root of 13. That may be about right. First square. So that. Yeah, that makes sense. So it's a 3, 2, which is not what I want. I wanted 3, 5. So that, do that times 2 plus 4. We should get that 11. 11 to 1. Yeah, that seems right. So that seems right. So let's do make a triangle. Let's do 10 and 12. I think that'll be a nicer value here. Let's see. 10, 12, and 25 maybe. What that does is both bases are 5, so then you have a 5, 12. That equals lost it. So the whole thing's 10, so each one of these is 5, 5, and then it's 12, and then get a triangle here of 144 plus 25. So perfect squares is the thing. 9, 1, root. That is 13. So then you have a 13 side. Just to check, but on that and squared is 13. A perfect square as well. So everything just works out. Then you have 13 and 13, which is 26, and is 36. Yeah, so I think my parameter's working out. The stars, that since it's a perfect triangle, it actually works out other values that sort of estimates. Could possibly work on that a little more if we wanted to. We could make it try to estimate a little better. Maybe we do. Yeah, we got time, so let's do that. Let's see what we could do. So let's do I'm trying to think of some way to do some math here. So we could do row plus one like we've got. Divide it by the height. What, the base maybe? Well, that would get us so on row plus one for the first row it's 1 divided by the height. So height is 12, so 12th of it divided by the base, which is 10. I would have to think on this. Maybe we're gonna say nah, let's not actually. He's gonna try to clean that up, but yeah. All my thoughts on how to clean up the sample there, not sure if they're gonna work. So this is completely experimental. So let's do stars equal. We'll have to cast it to int because math dot round. So rounds the decimal to the nearest integral value, rounds midpoint values to the nearest even number. That's important so it doesn't round like you would normally do. So you're at 3.5, going to round up to 4. You're at 3.1, again it's going to round up to 4. So that's one thing to keep in mind. That may not be exactly what you want. Let's do row plus 1 divided by the height. Multiply by base. We need to add print thing. There we go. Let's see what that does. That may be what I want. Now instead of this, we just do the stars. There we go. So that should. See what that looks like. I think that'll do what I want. So here, perfect, or one that works out perfectly, I think will be easy. Um, do my thinking wrong? Wait a minute. It should just be a double. Should be a double already, though. Yeah, the cast is redundant. Yeah, that's it. Hmm. Well, I guess we won't do this because let's just see the counts. It looks like they're all 0 and then max. I guess that's the times basis. Wait a minute. What I want the 1. Yeah, this. Yeah, this. Oh, wait a minute. Yeah, round shouldn't be doing that. Round should be everything, right? Very easy to get off on these, but I think that I think it's still wrong. Double. Not here. And we don't need this one. Yeah, I've got my parentheses all messed up now. Let's undo some of this. I think this double here should row hot. Get rid of one set. Times base. Let's do it like this. Okay. There. I think that gets us what we want. And I'd still rather have this in parentheses to be clear about the order. Yeah, it's technically not required, but I think that's how. Let's see what this does. See if that was a mistake. Because getting the base out of my rounding there would probably mess it up. Yeah, there we go. So had a problem with the parentheses. Move this line. On this one, it should now look similar. The rounding here is a little different, but I think this will do better on other shapes. Go change my shape here to something more irregular. Let's do 23 and 14. Something a little more irregular. Let's see what happens. I think this will round us out just. Yeah. Or an ASCII representation. I think I'm happy with that. It just sort of adjusts how it looks based on the rounding, and that should even us out on the edges a little bit. One fewer here than it needs to be, but at the height of 14, at a height of 34, it has a little more resolution. This will be a giant one that's going to take up way too many lines. I think you should see, yeah, that sort of would have a sort of ASCII art triangle. That's what I'm going for. So let's undo that. Let's go back to some good numbers. 12 and 10. 12 and 10. So yeah, so it looks a little worse because of the rounding, but some of them will look better. So I think I'm going to keep the rounding. But there's just a little bit of math, a little bit of looking at inheritance and object-oriented programming a little more, and a little more using what we've learned. So let's go ahead and recap. So in today's lesson, we have created a small little program here that creates some shapes and then adjusts the shapes based on the create some shapes and then find some stats about those shapes. So here, for example, we have a circle. We get the area, perimeter. It might should be circumference instead. We then draw a ASCII representation of the item. Do the same thing for rectangles and triangles. We're doing all those from the same shapes, which is our base class. We have an abstract base class, and that means when you inherit from it, or you can't just create it. So if we come over here and try to do comma new shape, I don't care. Here it's telling us we have a warning. We cannot create an instance of an abstract type or interface shape, and it won't let us create it. And that's our intention here. We're saying this is something that always needs to be inherited from, and when we inherit from it, we need to fix any abstract methods or properties and make them real. Virtual says similar as well. It says you can make these, can adjust these, or you can use mine. We seen that in the lesson. From there, we implemented 3 classes here. We implemented a circle, which inherits from shape, and it has a radius. You see here it passes in the base name, so this goes back to shape and passes in the name of circle. That way it identifies the shape. We overrode the methods here. We looked at expression bodied members. That's just a shorthand to do exactly the same thing here as a return. We also looked at the static system.math here. We looked at constant. We used over here in triangle, we used round, square root, and power. And you'll notice if you look in the system library that math has a lot of useful mathematics. So you can things like this a little easier. Yeah, that's most of what we covered today. Get perimeter here, get draw. We overrode each of the draws to draw out a little ASCII representation. So I won't say a good representation, like there's some funny rounding. You do decimals here, you're going to find that these get off very quickly. Same thing with the circle, but circle's all constant. Circle's always going to look like this because we could probably come up with some way to represent that a little better, but I'm going to leave it for there. One thing we could do, since we do have just a little more time, we could do a check over here. Let's do this. So this is entirely optional, entirely going beyond what we've done, and going to be entirely new, something new that you won't have to use very often, but I'm going to use it here just to show that you can do something like this. You can check the type of something. Well, if type of shape does not equal type of circle, then we do this. Shape is not right here. Shape dot you can't do. Wait a minute. Oh, I may not be able to do it. So that, let's try this. Shape. If shape is not a circle, do this. If it is, let's see what that does. Let's see if that does what I think I'm going to do. And if it doesn't, we'll revert, but going entirely off the rails and completely past my planning, but see a new keyword there. Okay, circumference. So it changed it. So what we did there is something I haven't seen but might see in the future. So we checked the shape and we said if the shape is not a circle. That reads very nicely actually. So taking this shape and it's checking if it's a circle or not. So it's taking the base shape because each one of these is just a shape, and what in the inside it's something that's inherited from shape, so it fits into the array. And here we're just saying if it's not a circle, we go on and we print perimeter. You can use that occasionally for something like this. Is probably a decent example of this actually, though, where a perimeter of a circle would technically be a circumference. Technically, perimeter should also be fine, however, so leave it, but I'm going to leave it like this. Makes more sense to me. I think that covers all I was going to cover. Yeah. So basically from there, I may do one more lesson where we do a little bit more with an maybe inheritance, maybe trying to add just a little more to it. But I think I'm very close to. I think we're very close to where we want. So next time, I think next time we're going to do one more of these, a little app that just play around with creating objects, creating inheritance structures, and yeah, I'll have to think on that. But I think I want to do at least one more. So next week maybe it's very similar to this video where we create a little program to do something with some kind of inheritance model and just play around with that. That may be the goal of next week. After that, we may actually start on touching on a new topic. But yeah, so that'll do it for today. So thanks for watching. This has been Shadow of Shadow Gaming. Thanks and have a wonderful rest of your day.